All right, so this morning for week 3, Monday, I'm going to cover the lessons that we're looking at this week, 105 and 1.06, writing the equation line and comparing functions. That's what our lessons are this week. So I want to cover those. And you do have a quiz that is due for the last week's stuff, which will count in your evidence of learning grade. So let me pull up my camera on my desktop here just to be able to show you some stuff. We're going to talk about writing the equation of a line. We're talking about 3 different ways to do that. I know we generally think in writing the equation of a line, we just think of y equals mx plus b, right? We have a slope, we have the y-intercept, and we just generally think about writing equations of lines that way. But we need to be flexible to where we can write it other ways also, because it's very useful depending on what information we have or for what information we need. So let's talk about the 3 different forms that we're going to look at for equations of lines and different ways that you will see the equation of a line. So y equals mx plus b, that's the one you're used to, right? You'll see y equals 3x minus 7, right? We're used to that. That's one of the earliest forms of a line that we saw. So this is the slope-intercept form. Slope-intercept. Because what information do you get? You get the slope and you get the y-intercept, right? Slope-intercept, slope-intercept. So that's why we call that the slope-intercept form. Raise it up just a little bit. Okay, and then another form will be the point slope. And that would be when you would see, let me just write an equation, y minus 2 equals 4x plus 1. That is y minus your y point, because this, if you have a point, an x1, y1 point, and you have a slope, actually a slope of 4 or whatever, equals the slope times x minus the x coordinate of the point. So whatever your x, I'm going to highlight those. So if you have an x and a y, your x and y go right in your equation, then your slope would go right there. That is the point slope form of a line. So we can write a line like this, and we can write a line like this. And the other way you'll see it is just the standard form. It's funny that it calls it standard form, because standardly we use this one, right? Or sometimes this one. But the standard form of a line would be where we have like 2x plus 4y equals 8. It's ax plus by equals c. And this tells us nothing. We don't know a point. We don't know the slope. We don't know the y-intercept. None of that information, when we look at this equation, that 2, 4, and 8 is not any of those. It is not the slope. It is not a point. It is not the y-intercept, but it is what is known as the standard form, because we have the variables on one side and the equation equals a constant. And so that is generally the standard form of a line, ax plus by equals c, where these are all integers and a is a positive number. So that is the 3 different ways that we are looking at it, especially in this lesson, different ways to look at equations of a line. So Other things that we need to know in this lesson is if we have 2 points, we need to understand the equation of a slope. If we want to find the slope, m equals, and we have to put the y's that we have, y2 minus y1, and divide it by x2 minus x1. So if we have a point, let's say we have the point 1 comma 2, and we have another point negative 2 comma 5, and we want to know, can we write the equation of the line that goes through those 2 points? Okay, all we have is 2 points, and we want to write the equation of the line that would go through there. Well, the easiest way to do that would be point slope, because we have a point. We actually have 2 points. We can pick either one. We just need to know what the slope is. Well, we have an equation for slope. So the slope would be y2 minus y1. We can pick whichever one of these want to be point number 1 or point number 2. So let's just say this is point number 1, this is point number 2. So point number 2, the y is 5. And then subtract the y from point number 1 over the x from point number 2 is negative 2. Subtract from number 1. So the slope is 5 minus 2 is 3. Negative 2 minus 1 more is negative 3. So the slope is negative 1. So if we want to write the equation of the line using either point, let's just take the first one. Y minus whatever the y is, y minus 2 equals the slope, which is negative 1, parentheses, x minus, what is the x? It's 1. That is the equation of a line that will pass through those 2 points. We could also do y minus 5 equals negative 1, x plus 2. That's a negative 2, so that would be x minus negative 2, which is x plus 2. These are the same line because we use the point slope method, and we just chose the first point for this one, and on the first point for this one, second point for this one, same slope. Those are both the same line. Point slope, we can use either point and come up with an equation that will graph that. And you can always go to Desmos and type that in. In fact, that's a good idea. Let's do that right now. Let's go to Desmos and check to see if we enter those, does it actually go through those 2 points? All right, so I'm going to put up Desmos on the screen. And I'm going to put our 2 points first. We had the point 1 comma 2. Label that one. I'm going to put the point negative 2 comma 5. Label that one. So there's our 2 points. Let's blow it up a little bit. Can't put too many grid lines on that. Let's just look at ones. All right. All right, so there's our 2 points. Let's put the first equation of a line we had. We had y minus 2 equals negative 1 parentheses x minus 1. Look at there. That line went right through that point and through that point. It went through both points. Then we said the second equation of a line, just using the second point instead, would be y minus 5 equals negative 1 parentheses x plus 2. Look, same line. It's purple. First one's green. So either one of those are the exact same line. And this plus 2, we said, is actually minus a negative 2. Well, you can write it as minus a negative 2 if you want to. It's still the same line. But simplifying x minus negative 2 is just x plus 2. So when we graph that, we see that it absolutely does create a line that goes through those 2 points using either point. So point slope, we could even pick a new point. We could pick any point on that line and use that and write that equation line. We could also figure out the slope and pick pick the y-intercept, calculate the y-intercept and write the y equals mx plus b method. But we don't really have to do that because point slope is perfectly fine. That's a perfectly fine way to write an equation of a line. So point slope. All right. So lesson 1.05 is writing the equation of a line. So it will deal with writing this type of equation or writing this type of equation and standard equation. And you can convert those back and forth. If we needed to take this, but let's take the second one right here. Let's take this one we just did. It says, okay, you have this equation line. We would like the answer in standard form. Standard form. Well, this is standard form right here. If it says give the answer in standard form, but it just gave 2 points, we write the equation the only way we can right now, which is point slope, and then we'll take this equation and we will change it to standard form. So all we have to do is just do some algebra with this. So let's distribute and get rid of the parentheses. So we got y minus 5 equals negative 1 times x is negative x. Negative 1 times 2 is minus 2. So now, standard form, all the x's and y's are on the left side. Any constants are on the right. So we've got to move the 5 over to the right. We have y equals negative x plus 3. Oh, now we've got it actually in slope-intercept form. Y equals. And to change it to standard form, we just move the x over. So now we got x plus y equals 3. So there's the same equation in all 3 different forms. We have it in point slope form, we have it in slope intercept form, and we have it in standard form. Those are all the same line. We just use a little algebra to rearrange the equations. We rearrange the equations and we can make the same line be in point slope, slope intercept, or standard. Remember, standard has both variables on the left side and the constant on the right side, which is all we did is we just rearranged it to do that. So that is the big highlight points of 1.05. If you can manipulate those, if you can write equations in those forms, rearrange them to be whichever form you need, then you have 1.05 down. All right, so let's look at 1.06. 1.06 is about comparing functions. It's great to be able to write things, but we need to be able to compare functions, not just linear functions, but any functions. It could be a quadratic, could be all kinds of different stuff. And we need to be able to compare that. So with linear functions especially, we should be able to compare. What can we compare? Let's see, compare. With linear functions, we have a slope, right? We don't have a slope with quadratic and many of the other ones, but we can compare slopes, right? We can compare y-intercepts. And we can look at increasing, decreasing. If you have 2 linear functions, these are 3 things you definitely would want to talk about. If we said compare these 2 linear functions, you would definitely want to compare these things. You'd say, well, the slope of the first one is -2, and the slope of the second one is 1/2. What is the y-intercept? The y-intercept of the first one is 2, and the y-intercept of the second one is -5. And the first one is decreasing, and the second one's increasing. And you want to compare those different things on there. So there's different other features you can pull out, but those would be with linear functions for sure. Linear. You want to at least pull out that information there. If there's other differences you can pull out there, that's great. Other things going to talk about in 1.06 is different ways to represent a function. That's where it gets tricky. If I give you 2 equations, sometimes it's pretty easy to do, but sometimes you don't have 2 equations. You may have at one equation, it says we're going to give you like 4 functions to compare. So the first one will give you that. And then the second one, maybe it gives you a graph, right, where you've got to find the slopes. And all you have is a graph. And then the third way, they give you an XY table, right? So it's like, great, I've got to compare those functions. It's just different ways to represent. And over here, may say Sally had an apple. Had an apple. She bought 3 more each day. Another function. So 4 different ways you could have a function. F of x equals 2x plus 3. Algebraically, they may give you just the equation, a graph, a table, and then they may give you a verbal, like a story, like a word problem type thing. So you have to look for ways to compare that. So if we had, for example, we want to compare the slopes, because we said that'd be one important thing. These are all linear. So what would the slope be? This one, the slope is 2, right? Because it's a 2x. What is the slope of this one? Well, let's see. It looks like it goes up 1 over 1, up 1 over 1, up 1 over 1. So the slope would be 1 here. I didn't draw that terribly well, but we'll say the slope is 1. What's the slope here? As this x goes up 1, that goes up 2. It goes from -5 to -3, -3 to -1, -1. So this has a slope of 2. And what's the slope here? Sally had an apple. She bought 3 more each day. So she bought 3 more apples. So every day she added 3 apples. So that slope is 3. So comparing the slopes of these 4 equations, we see 2, 1, 2, and 3. These are the same slope, and these are different slopes. If we were looking at the y-intercept, the y-intercept here is 3 because it's the plus 3 on the end. What's the y-intercept here? It crosses right there at the 1. So the y-intercept is 1. This, where the x is 0, that's where it's crossing the y. So that one has a -1. And this one, Sally had an apple. She started out with just 1 apple. So when we compare y-intercept, we find that these two are the same, where these two had the same slope. All right, so we look at key features. And we can say, are they increasing or decreasing? Well, these all have a positive slope, so they're all increasing. So we have to be able to compare functions given different representations, right? Whether it's an equation, a graph, a table, or a story problem. So this is the main idea behind lesson 1.06, is being able to look at functions, and we're looking primarily at linear functions because that's the easiest thing to pull things out of, and comparing, contrasting, seeing what's the same, seeing what's the difference between all of these. So that is the big highlights. So this week, what is due is we have the quiz, which covers last week's material. Then you have 1.05 and 1.06, which is what we just looked at right here. Learning to write linear equations in 3 different methods and comparing them with the highlights of the things you would need to make sure you compare and different representations and how they present it. So questions on that? Does it kind of give you a good overview of it? Certainly go through the lesson. I mean, this is just an overview of it, but go through the lesson. It gives you some good examples. It gives some videos in there. It'll step through how to do these things slower than I did. I've done it all in about 20 minutes, but it'll go through and step by step to where you can get all of that. So if you have any questions, be sure to let me know. Do you have any questions over what was due last week? Did that go okay? For those of you who got that done, I'll kind of make sense on there. So, all right. Well, if you've got that figured out, that is an overview. I'm not going to keep you any longer. I'll let you go. If you've got your work done from last week, you're free for the week to just work. You can come to class if you need help. I will still come to class the rest of the week. But even if you don't have to be here, you can come by if you got problems. But don't wait till like an hour into class, because if no one's here, I won't stay. But anyway, go and enjoy your Monday.
Let's get out of here. Word to your multiples. Math, baby. We're learning math, baby.